So I'm going to be giving you a simple example in this particular lab just to demonstrate the various measurements of our spread. This is just an example of blood glucose level in milligram per dl, mg per dl, in mg per dl. I'm going to run this. So we have 10 observations. Now I'm going to calculate the range. So when I calculate the range, I'm going to get 58. You can see that we have 58. And when I calculate the variance, also glucose variance, I can see that my variance is 360.05. This is the variance. If I want to get the standard deviation, I have two options. I could decide to just take the square root of this. I could just say square root of the glucose variance, which is 18.97, or I could just decide to use the standard deviation function and call the standard deviation, which is also 18.97513. So these are the various two ways I could use to get the standard. So you can see, which means that the spread of various observations inside our data set from the mean is 18.97. So this is how you can interpret the. So the main measurements of spread I'm going to be explaining the interpretation, which you are going to be using in real life cases, is the standard deviation. So now you can see that we have 18.97 as our standard deviation, or let's just say, let's approximate it to 19. Our standard deviation is 19. Let's just approximate it just for example sake. And now let's get the mean. Let's see what the mean of our data set is. So the mean of the glucose levels is 120. Since the mean of our data set is 120.5 and the glucose standard deviation is approximately 19, then what means standard deviation of the glucose levels to be 19 and also approximately the mean to be 121, then we can now say that most of the observations we have in our data fall within the range 121 minus 19 to 121 plus 19. So if I say 121 minus 19, we have 102. And if I say 121 plus 19, we have 140. So it means that most of the observations 102 and 140. As you can see, that is actually true. Most of the observations fall within that particular range, because you can see 105 falls between 102 and 140. This 110 also, 120, 125, 130, 135, and 140 itself. We have 1, 2, 3, 4, 5, 6, 7. 7 observations falling within that particular range. So this is what the standard deviation means. So once you have your standard deviation, you subtract it from your mean to get the lower boundary, and you add it to your mean to get the upper boundary. Observations falling within that shows majority of the observations in the data set. This explains the spread of your data set. The interpretation of the standard deviation actually. So the next is the coefficient of variation. So you can just use this by calculating by formula. Since we already have the standard deviation and the mean, I will multiply it by 100. So when I run this, okay, I've not calculated the glucose mean. So when I call I have 15.747 as my coefficient of. Now we have various measurements of blood glucose levels. Now currently I'm using mg per dl. What if I have millimeter mole per liter? Now millimeter mole per liter is another measurement. I can't compare their variance and their standard deviation. So I want to see the spread. So because this particular one now was from a hospital, and I have another blood glucose levels in millimeter mole per liter. What I'm going to do is that instead of using the various measurements of spread we have, I'm going to take the coefficients of variation. So I now took mg per dl. I now found out that the coefficient of variation is 15.747. I now took that of millimeter mole per liter, and I found out that the coefficient variation. So what this means is that the one of millimeter mole per liter has a lesser spread than that of this other data set I have, which is the mg per dl. So when you have two data sets and you're trying to compare the coefficient of variation, the one with the lower value has a lower spread or lower variability compared to the other one with the higher value. So this is the interpretation for the coefficient of variation. I usually use when you're comparing various data sets with different